The James Webb Space Telescope is the ultimate cosmic microscope. It cost $10 billion, took 13 years to build, and provided the first clear look at the formation of the very first galaxies. Yet, for all its power, Webb is looking at a tiny fraction of reality. Every star, planet, and grain of dust humanity has ever observed fits into this 5% slice of visible matter. The rest is a total vacuum of information, 27% dark matter and 68% dark energy. We know dark matter exists because of a massive physics discrepancy. When astronomers look at the edges of a galaxy, stars are moving too fast. The gravity from the stars and gas we can see isn't enough to hold them. Without the pull of an invisible mass, these galaxies would simply fly apart. Dark energy is even more mysterious. In 1998, we discovered that the expansion of the universe is actively accelerating. Something is overpowering gravity on a cosmic scale, pushing the very fabric of space apart at an increasing rate. Even with the most advanced optical equipment ever launched, humanity remains effectively blind to the primary forces governing the universe. Webb was never designed to solve these mysteries. Because it was built for extreme microscopic detail, its field of view is incredibly narrow. You cannot map invisible, large-scale structures by staring at one isolated object at a time. It is impossible to see the shape of a forest if you are only allowed to look through a straw at a single leaf. To find what's missing, NASA is shifting strategies with the Nancy Grace Roman Space Telescope. It is currently in final testing for a 2027 launch, and it was built for the specific purpose of mapping the unseen. Finding the missing 95% of the universe requires a change in perspective. We don't need to look deeper, we need to look wider. Roman uses a 2.4-meter mirror, the exact same size as the mirror on Hubble. At first glance, that sounds like a step backward compared to Webb's massive gold arrays. The leap forward is in the detector. Roman carries a 300-megapixel camera that captures an area of sky 100 times larger than Webb in a single frame. While Webb provides extraordinary detail on one specific galaxy, Roman documents the behavior of 2 billion galaxies simultaneously. This creates what astronomers call statistical resolution. The mechanics of the universe are found in the aggregate behavior of billions of objects, not just the visual clarity of a single one. Mapping the invisible depends on a principle from Einstein's general relativity. Anything with mass curves spacetime, and light follows that curve. Dark matter has mass, so its gravity distorts the light of galaxies behind it. By measuring how the shapes of millions of background galaxies are warped, Roman can reconstruct a three-dimensional map of where the dark matter is actually hiding. For dark energy, Roman will monitor the brightness of distant supernovae across 10 billion years. This allows us to track exactly how the expansion of the universe has changed over time, revealing if the force pushing space apart is constant or fluctuating. A secondary mission will use these same gravitational distortions to find thousands of exoplanets. Because it watches so many stars at once, Roman can detect cold planets in the outer reaches of solar systems, worlds that current telescopes miss. Ultimately, Roman is a measurement engine. It turns the observation of light into the direct detection of invisible mass and hidden planetary systems. Webb and Roman work as a tag team. Roman will map the macro structure of the sky to identify anomalies, and Webb will then move in as a precision scalpel to investigate those targets in detail. This strategy is the legacy of the telescope's namesake, Nancy Grace Roman. She was NASA's first chief of astronomy and the first woman to hold an executive science role at the agency. She spent the 1960s fighting to prove that the expense of a space-based telescope was necessary to see the universe clearly. Her work created the program that eventually became Hubble. This new observatory is the fulfillment of her vision, a multi-tiered system that looks at the universe from above the atmosphere to see what is impossible to observe from the ground. In astronomy, the most significant discoveries are rarely the ones listed in the original mission proposal. Hubble was built to measure the expansion of the universe, but it ended up finding the first atmospheres of planets outside our solar system. When Roman launches on a Falcon Heavy in 2027, it will begin a 5-year survey of 2 billion galaxies, a volume of data that dwarfs any previous mission. Surveying the universe at this width and resolution ensures that Roman will uncover phenomena we don't yet have the names for.